Alright, so let's start with this problem now. Longest substring without repeating characters. Okay, so you all know what a substring is. Substring is nothing but a continuous block of elements in an array. In this case, a string. So continuous characters forming a string within the string is substring. So we need to find the maximum length such that there are no duplicates. Alright. So let's think of a brute force solution. A brute force solution can be you can use two loops and then from here A onwards you will check if you are seeing a repeating character in this case, and in order to do so you will maintain a map. So if you see that ABC, okay, nothing problematic till now, but when you see A again, so A's frequency map will be increased to 2. So at this point you will stop. So you will just take this ABC length into consideration, and then again you will do this process from B, BCA, and then B again, BCA, just 3, and again from C, and so on. So this method will take at most n square time complexity, but that is the extreme naive solution. Now we need to think of a better solution. So this is a very standard problem for sliding window. So think in sliding window terms. Now let's go through our algorithm verbally. Let's say that there are two pointers. One is L and one is R. Initially, both are pointing to 0. In this example, at this A. So we run a loop. So basically, we want to find the maximum length between R and L. R can go a maximum till N, and L will always be behind R. Okay, so initially in order to keep track of the frequency of each character, you can have a map, you can have a frequency vector, or you can have a set, that is up to you. So we will keep track of every element's frequency. Initially, when we are at A, we will increase its frequency by 1, then we move on to B, we will increase its frequency by 1, and so on. C 1. Now when we encounter A again, we see that already the frequency is 1. So after doing that, our frequency is greater than 1, and we don't want that. So we begin to shrink our window. How do you shrink your window? By moving your L pointer. So now you move your L pointer, and at the same time you decrease the frequency of whatever character was present at L, and then you move your L pointer, and you do this up till your R has finally reached the end of the string. And in doing all this, you keep track of your maximum length. So let's just code it up for better understanding. Initially, just writing the size of string as n, and as I said, we will need two pointers, left pointing to 0, right pointing to 0, and we need a map or a set or a frequency vector, whatever. So I am using a frequency vector here, which will be of type n. Let's name it MP. Okay, and I will, since it is given to us that S can only consist of English letters, digit, symbol, spaces, etc. So we know that it all falls under, I think, 128, but to be sure, let's keep it 150 and initialize every frequency to 0 initially. Then we move our pointers here. So while my right is less than n, which is the size of it, what I said, first my current pointer is at right. So first I will increase the position of, first I will increase the frequency of this right character by 1. And then I will check if this particular value, if it exceeds 1. If it does, I need to shrink my window. Before shrinking, I want to decrease the frequency of the left character. So I do something like this, and then I do left plus plus. And after doing this, I also keep track of the maximum length. So let's have a variable, let's say max length. I will initialize it with 0. So my max length is equal to max of max length comma my r minus l plus 1. So why r minus l plus 1? Because that's the number of characters between r and l, including r and l also. Alright, and now finally let's move our right pointer and then we return our max length. Let's run and see if it runs fine. Identify, okay, r is my right and this is left and this is right. Okay, bingo. So let's discuss the time and space complexity of this solution. So what about the time complexity? We just have 2 pointers left and right initialized with 0. At every point we are just iterating through right, and our right is at most going from 0 to n, and our left is also at most going from 0 to right itself, so eventually n. So at most we are just traversing it 2 passes, so it's a time complexity of big of n. And the space complexity, are we using anything extra? No, we just have the 2 pointers and also this vector of map which is of size 150. I mean it's just constant, but I'll still write it 150, so it's still a constant value, right? So let's submit. Perfect.